Welcome back once again, guys, okay? Let's keep pushing. And remember, to do well is consistency. Is not putting 100 hours or 5 hours on Saturday. It's about that consistency that will get you through, okay? And I know sometimes when you're doing your maths, it can be difficult. Solving a problem, you have no idea, okay? But I would say it's persistence that will keep you going. And it's okay in mathematics that you're working on a problem you have no idea. I think that's the nature of it. What is important is what do you do with the challenge, okay? So look at some of the examples. Ask questions, seek help, okay? That's very important. And if you're consistent, you shouldn't be there struggling heavily when it comes to your mathematics. What I mean consistently is that rather than put 30 minutes on a daily basis, not because you're preparing for tests, you're studying to understand what you're doing. And if you start early, you'll definitely do. It will be impossible. You want to cram lots of work in 4 hours because you have an assessment or a test tomorrow. It's really impossible. It's the consistency that will get you through. Okay, great. So we were discussing what is range, and we discussed as one measure of dispersion. And we said range is defined as the maximum minus the minimum value. Okay. I mean, let's say there's a company, and the person who's paid the highest salary in the company minus the lowest, there's a huge deviation. There's a gap. It implies in that company there's inconsistency. But if I go to another company, I go to the guy who's paid more money, minus the lowest, and the difference is not that big. Oh, there's consistency in that company based on the range. Okay. Good. But range is not the best measure of dispersion. Okay. Are we together? Okay. Good. Let's see what we have now. So here, this data shows the population in millions of a random sample of 12 countries. Find the range of the population size. Okay. What is the range? Okay. Let's look at the range. The range is the maximum minus the minimum. So the range, which is the maximum, what is our maximum? The maximum is that. So it will be actually, that's the maximum value, and we have to minus the minimum value, which is the lowest value. What is the lowest value? The lowest value is 2.5. And if we minus the 2, maximum minus minimum, we get that. That's the range. The highest value minus the lowest value. What does it mean here? Okay, does it mean anything? Does it tell us anything? I mean, but if you look at the 125.6, it's kind of an extreme. Are we together? So range might not be the best measure of dispersion because it's very extreme. I mean, it's the biggest. I mean, it doesn't fit within that data set in terms of population. You look at it, you have 3.6 million, 5.8, you know, very close together, okay? Those are very close, okay? But if you look at that, I mean, it's one of the biggest from that set of data, actually, those two. Are we all together? And that extreme value can actually affect our mean, okay? If we have to calculate the average because the average is taking everything divided by 12. So the extreme value can affect our average. Okay. So range is not a good measure of spread. That's what I was saying. So the range is not a good measure of spread because one extreme, very, very high or low value can have a bigger effect. Are we all together? Let me go to the example of a company. if I compare salaries, how much people earn from working, and I take the person who earns the highest minus the lowest, and I minus, and I find, there's a huge gap between them. But what if that highest is the only one highest? And I'll say that corporation is inconsistent. But that's not really true. They just have one person earning low and the highest person, and one person earning the highest. But I don't know about the rest of the data. I don't know. So it's not really good because of that extreme value that we might think inconsistency, but actually if we mirror in the middle, we might find that the data is consistent. So if we look at the 5-number summary, this is what we have. Let's look at the interquartile range. So this measure of spread is liked to be the median. So the difference between Q1 and Q3 is the interquartile range. So let's look at the range. The range is the maximum minus the minimum, which give us the interquartile range, which give us the range. But the interquartile range is the Q3 minus Q1, is the range of the middle 50% of the data. And that far better than the range, because the interquartile range is not affected by the extreme values, the high or the lows number, because you're looking at the middle of the data. So that's the difference between Q1 and Q3. And if you look at your box and whisker plot again, so your interquartile range will be from there to there. That will give us our interquartile range. Are we all together? Because that's the difference between there and there, which is the interquartile range. Are we together? But the range, which is actually the max minus min, this is the range. Max minus the minimum value. So this can be one of the extreme value, the max and min, which can have an impact, mislead us about the range. But Q3 and Q1, which is the interquartile range, can actually eliminate those extreme values. Are we all together? Can eliminate those extreme values. Good. So the interquartile range. The interquartile range is generally a better measure of spread because it is not affected by the extreme values. So the interquartile range is not affected by the high and the low number. If I have an argument, somebody argues using range, I don't think it's reliable. I'll rather go with the interquartile range because the interquartile range is not affected by the highs and lows in making arguments or conclusions. Okay. So guys, what we looked at today, we looked at, remember that the measure of central tendency, talking about quartiles, average. We looked at the 5-number summary, which goes to the whisker plot. Then the measure of dispersion, which we looked at the interquartile range, the range, and the semi-interquartile range, which is the half of the interquartile range. That's the semi-interquartile range. So that is actually half of our, you do your Q3 minus Q1 divided by 2. Okay? So the semi-interquartile range. So the semi-interquartile range is half the difference between the upper and the lower quartile. The half difference between the Q1 and Q3. So you can find the interquartile range divided by 2, or half Q3 minus Q1. That will give us the interquartile range, the semi-interquartile. Because it's semi means half, interquartile we know is Q3 minus Q1. The semi-interquartile range is also not affected by extreme value on the score. It is good measure of spread for skew data. Remember, for skew data, skew to the left, skew to the right. So the interquartile range is best for that. So measures of what? Of spread. We had a range, interquartile, interquartile range and semi-interquartile range. We said that the range can be affected by the extreme, high, low, or small. The semi-interquartile range is better because it avoids the extreme, the lows or the highs. But the semi-interquartile range, it also avoids the highs and the lows, but it's good for skewed data. Remember, skewed will be to the left or to the right. So our summary here, what we have looked at today. So we have looked at the measure of central tendency, guys, which means we looked at our quartile, average. Remember, our quartile is Q1, Q2, Q3, which is the same as lower quartile, median, and Q2 the same, and the upper quartile. Then we look at averages, which is mode, agreed, median, and average. We also looked at group data. Then under, we looked at the 5-number summary, which links to the whisker plot, and the measure of dispersion range, interquartile range, and semi-interquartile range. Great, guys. I think I had great times with you, and I hope it makes sense, and keep working hard at home. We hope to see you soon, and this is bye from us.